In this last video, we are going to be finding the constant term in the expansion of this binomial. So again, the constant term is the term that has no variable. So as I was saying in the last video when I was trying to give you a clue, although we have x here and we have x squared here, there will be one point in one term when the x's actually cancel each other out, and it is at that point that we're going to have a constant term. So let's play detective again and look at what we know. Basically, all we know right now is that this guy is our n. So let's write out the formula. Tk plus 1 is equal to 15 ck, right? We know that this is our n, times a, and a is represented by 2x. So 2x to the power of 15 minus k. And then b, which is represented as negative 1 over x squared to the power of k. So what I'm actually going to do to make this easier is I'm going to change this from negative 1 over x squared to negative x to the power of negative 2. I think it will make it easier to do this calculation. So I'm going to do that right now. I'm going to erase this. I'm going to actually make this x to the power of negative 2. Oopsies, negative x to the power of negative 2. There we go. Now, from here, I know that I'm looking for a term that has no variables. So I'm looking for a term in which the exponent to my x's are going to be 0. So here, when I'm multiplying 15ck by 2x, because I'm multiplying, I'm looking at adding my exponents. So what I'm going to do first is I'm going to simplify this as much as I can, and then I'm going to look at how I can get those exponents to sum up to 0. So 15ck, I'm going to expand this exponent to the 2 as well as the x. I'm going to separate them. So I'll have 2 to the power of 5 minus k. Then I'm going to have x to the power of 5 minus k. I'm going to do the same thing over here with my next term. This negative right here, I'm going to treat that as negative 1, which it is, to the power of k. And then I'm going to have x to the power of negative 2k. So let's see if I can add some color to that to make it a little bit easier to see. Uh-oh. How about lines? Do those make it easier to see? Whatever. Okay. Here we go. So this right here, I distributed my exponent and ended up with this. And for this section, I distributed my exponent both to the negative 1 as well as to my x. And I end up with this. Now I'm going to combine my x's together. I can do that because I'm multiplying. My base is the same, therefore I can add my exponents together. So I'll have 2 to the 5 minus k, then I will have, oh dear, then I will have negative 1 to the power of k, and then I will have x to the power of 5 minus k minus 2k. So this exponent right here, in order to cancel out and in order for me to end up with a constant term, this exponent right here has to equal 0. So 5 minus 3k has to equal 0 in order for me to end up with a constant term. I need this to be x to the 0 because then it's 1 and then I'm left with numbers. I'm going to see if I can't fix this anymore. Oh, no, that was bad. Oh, that was very bad. Okay, we're just going to leave that. Okay, so for this to equal 0, oh, whoops, why do I have, oh no, everywhere that I had 5, I'm supposed to have 15. How did that happen? Okay, need to go back and fix 15, 15, 15. I knew something wasn't working out. 15. Okay, I think that's it. Good. So now I have 15 minus 3k is equal to 0. So 15 is equal to 3k. And so k is equal to 5. Perfect. Now I get to plug that in. So I'm ending up with, oh, I'm being so lazy. Look at this. I should have this all here. So now I know that k is 5, so I know I'm dealing with the 6th term. Too bad that wasn't the question, because then we would have it answered. But it's actually asking for the constant term, not which term is constant. So then I have 15c6, not 6, 5. What am I doing? 5. And then I have 2 to the 15 minus 5. And then I have negative 1 to the 5. And then when I plug 5 into here, I end up with x to the power of 0, which of course is 1. So I get to disregard. Now I can use my calculator to evaluate the rest. So 15c5 is 3003. Then I have 2 to the power of 10, which is 1024. Then I have negative 1 to the power of 5, which is negative 1. So final answer, negative 3,075,072. So once again, I apologize for all these lines. Maybe I can make them go away. I'll try one more time. There we go. Ta-da! So maybe pause it on this screen with no lines, and hopefully you're able to follow. So I'll recap briefly what I did again. Because I'm looking for a constant term, a term with no x, I used my detective skills and wrote out what it is that I knew. So I knew my n, to figure out what my exponent for x would have to be, or what k would have to be in order for this exponent to equal 0 and cancel out. So I did that by distributing my exponent, by collecting my x's together, same base, multiplying, so I added my exponents, and then I set that equal to 0 to find k. Once I found k, I was able to then plug it back in. So maybe I'll circle this step, which I plugged in after here. Right now I know what k is, and then I was able to evaluate that term. See you tomorrow.